So just for
Okay.
the quick revision, what is the Newton's first law, second law, and the third law? Okay, so the Newton's first law is about the inertia. Okay, it's about
Yep.
the inertia. Then the second law here, this is basically about the definition of the force, saying that like the force is basically the rate of change in momentum, delta p over delta t. With this, we can say that delta p is equals to f delta t, and over here, if you are plotting a graph of f versus t, then the area under the graph, this area under the graph, this gives you delta p, or you can say this is the impulse. Okay,
Yep.
yeah. And then we have the third law, which is basically the law of action and reaction. Okay, action and reaction pair. This says that like the action force is equal to the reaction force, but in the
Yeah.
opposite direction. So I should show the negative sign there. Now remember one thing, that this action and the reaction pair, action and reaction forces are on
Yeah,
two
it means that
different
all forces
objects.
come. Yeah, they're on two different objects, but it also means that momentum is conserved in any system because
Yes,
forces come in pairs, and because it's a positive and negative pair, the sum of those forces and the impulse they impart is, well, zero. So,
yes, absolutely. So it is simultaneous, and also the so action and reaction, and they are the opposite. Opposite means the angle between them is 180 degree. Angle between them is 180 degree. All right. So this is the first, second, and the third law. All right. So let's go ahead. So let's continue with the next thing, and that is the law of conservation of momentum, which you just said. But I'm explaining this thing with a specific example, law of conservation of momentum. Okay, so if I'm considering here, let's say two balls, this is m1, which is going with the speed u1, and then we have another ball which is m2 going with the speed u2. Okay, so what do you think is the total initial momentum? What is the total initial momentum?
M1 U1 plus M2 U2.
Definitely, this is m1 u1 plus m2 u2. Now let's say that
What's
like they are going to
what?
collide.
Oh, they're colliding. Okay.
Yeah, now let's say that they are colliding. So then in that case, what actually happens, that certain amount of force, so we have a kind of force being exerted on second block. There will be one thing, at the same time simultaneously another force will be exerted on the first block, and they are basically
Yep.
making the action reaction pair. Okay,
Yep.
what you can say over here, that f1 is equals to f2. Okay, or more precisely minus f2, basically, because they are the vectors.
Yep.
Yeah.
Yep.
Okay, now let's say that like after a collision they get separated, and now they are moving with a different velocity, let's say v1 and v2. Okay, remember, I'm talking about the velocities, I'm talking about the forces, that means I'm focusing on the vectors. Okay, what is the total final momentum over here?
The total final momentum will be the same as the initial momentum.
No, I haven't yet proved it. Okay, so the total final momentum in this case is m1 v1 plus m2 v2. Yeah, that's what I should actually say. All right,
Yes.
now let's prove this. Let's prove what you just said. So we have one thing, f1 is equals to minus f2. But what is force? Force is the rate of change in momentum. So f1 will be the m1 v1 minus m1 u1 over certain time taken, and f2 is m2 v2 minus m2 u2 over the same amount of time which is taken, okay, during the collision. Agree? T will get cancelled on both the sides, right? So what we have over here, we have m1 v1 minus m1 u1, which is equals to minus m2 v2 plus m2 u2. Now you can take this m1 u1 on the right hand side, m2 v2 on the left hand side. That makes it m1 v1 plus m2 v2 is equals to m1 u1 plus m2 u2. All right. Now, what is this? This is the total initial momentum, the final momentum, and this is total final initial momentum. So this is saying that like the total momentum is conserved, given that There is no external force. Okay, there is no external force. It is a closed system basically. Okay, there is no friction involved. There is nothing like no other forces we are considering. Okay, then in that case, the total initial momentum equals to total final momentum, and this is the law of conservation of momentum. Okay, I hope this is clear, right?
Yep.
I'm giving you
Clear.
a few questions. While doing the questions, make sure that you're working properly with the vectors, because you need to actually consider the sign conventions also. If it is on the right hand side, take velocities positive. If it is on the left hand side, take velocities negative. Okay, cool.
Yep.
So here is the question. Let's say this is 10 kg block, and here we have 5 kg block. Okay, and this is going in this particular direction with 2 meter per second, and this is going in this particular direction with 1 meter per second. Okay, now
Yep.
after they collide basically, and they collide. Okay, and then after collision, what is happening is, after collision, what is happening is that this 5 kg block, starts going in the right hand direction with the speed of let's say 1.5 meter per second. Okay, so what do you think will happen to this 10 kilogram block that you need to define? Okay, so this is case one. There is another case that after collision, we'll keep it separate. After collision, both of them start moving together. They stick to each other. And then they start moving with a specific velocity v. So what is that velocity? So these are the two situations, case 1, case 2. Determine the velocity of the 10 kilogram block in the first case, and the combined velocity of 10 and 5 kilogram block in the second case. Come on, do it.
Case 1, the velocity of the 10 meter block is 1.75.
1.75 you're saying, is it?
Yeah. Yep.
Right. On the right hand side, left hand side?
It's to the left, so it should be negative. My bad.
Are you sure?
In case 1, right?
Yeah.
Oh, I messed up my algebra. Just really quickly. Makes sense. I don't even know.
You need help?
Okay. No, I did some recalculation. I got negative 0.75 meters per second. Hello?
Yeah.
I got negative 0.75 as my answer for case 1.
Negative 0.75 is the wrong answer.
So it's not a comparison of the initial momentum to the final momentum?
Yeah. So see, what is the
It's
initial
not-
momentum? Initial momentum is 20 minus 5. That is 15.
Yes.
So the final momentum also will be equal to 15, which is 10 v, which we want to determine v, and plus 7.5. Agree?
Why would it be plus?
Because it is going on the right hand side.
Right, yeah, okay. That I don't doubt that. I got 7.5 in this one as well.
So
Okay,
then
so I
v
guess
will
I
be
just
equal
messed
to
up my algebra.
v will be equal to 0.75 positive.
Yeah.
Because here you are getting positive answer. That means it is going on the right hand side.
Yeah, I don't know why I just assumed x would be negative. Ugh.
Okay, so I hope this is clear. Yeah.
Yeah, it's clear.
All right. Tell me about the second case, case 2.
Uh,
Do it the same way. Determine the
yeah,
initial
it's
momentum.
literally the same thing.
Initial momentum is 15. Final momentum also will be equal to 15.
Yeah, and if it's 15 times v, then the final velocity is 1
Absolutely.
meters per second.
So velocity will be equal to 1 meter per second. You are getting positive answer. That means both of them are moving in the right hand direction. Okay.
Yeah. Okay.
Now, further in this particular question only, further what you have to do is determine the impulse. Let's name it A. Let's name it B. Here also this is A. This is B. Okay. What you have to do is you need to determine the impulse on A, impulse on A, impulse on B. Those in second case, impulse on A and impulse on B. You need to determine. Okay, come on, do it.
Uh, impulse on A, impulse on B. In the first one, what is the overall chain of momentum? Well, we have two velocities. So begin with A, we have, let's say 1A. We have 20 kilometers, or I said 20 kilometers. 20, what's the dimension here? It's going to be kilogram meters.
What is impulse by the
Kind of
way?
weird.
Impulse is
Yeah,
the
impulse is the
in
change in momentum. I know.
Yes.
20 kilogram meters minus, or yeah, pretty much just the difference. Minus, well, we already know what the other momentum is. We've calculated it as 15v1. Nope, not 15v. What am I saying? Was it 7.5? It was 7.5, yeah. We know it's 7.5. I guess then the change would have to, it's in the same direction though.
Your phone making noise.
Yeah, sorry about that. My friend's calling me. I can't talk right now. 10 kilograms. Why is this should not be this hard to approach. Okay, so we have the
See, impulse on A will be
hang
the.
on.
Right. Okay.
Sorry,
All
please.
All right. Okay. All right.
We know that the final momentum for object A is equal to 7.5, so that's V minus U is which is 20. That's equal to negative 12.5, I want to say.
Yes, you are absolutely
negative
right.
12.5
kilogram meter per second. Now tell me about the impulse on B.
The impulse on B, what is it? Well, is that 1.5? Yeah, so it's also 7.5 meter final.
Do it without calculation. Tell me the answer without calculation.
Tell you the answer without calculation. Well, I mean, the change is, but the change here is different because its velocity vector changes. It is not in the same direction, meaning that essentially what happens is the final velocity vector is negative 7.5, and our initial velocity vector.
You're doing a lot of calculation. I'm asking
I'm not
without
calculating. I'm thinking. I'm thinking.
All right.
4.5.
Yes, absolutely. Yes. The thing is, the total impulse you told me in the beginning that should be 0. So if you're getting this to be minus 12.5, the answer for this will be 12.5. Simple.
That's fair, actually. Yeah. Didn't need to think about it as much. Okay, this one, impulse on A, impulse on B. Why am I getting messages? Impulse on A. You found the velocity is 1 meter per second. A little bit weird, to say the least. I mean, if they're both moving together with that speed, we know that the speed of each object is 1 meter per second because they're essentially one object at this point. In that case, then we have 20 meters per second, or 10 meters per second minus 20 is equal to minus 10, which means that for the other object, it should be 10.
This is minus 10 and this is plus 10, you said, right?
Yeah.
Absolutely. Very good. Shabash. Very nice. Okay.
Okay.
Now let me give you slightly the complex ones now. These are like easy questions, very easy questions.
Okay.
So here is the next question. You have this kind of coordinate system. Basically, you have a block A, which is moving in this particular direction with the U, and block B, which is moving in this particular direction with V. Ultimately, at this particular point, they meet. Okay, they are coming from certain distance that like they're going to collide, and they basically fuse to form a combined sphere, a bigger sphere, which is A plus B basically. Okay, yeah, and then they start moving in this particular diagonal direction. Now let's say that this B, the mass of this B is 10 kg, mass of A is 5 kg. Okay, and this after collision, here the collision takes place, or the fusion takes place, basically, you can say. The fusion takes place. Okay, and then this fused sphere, A plus B, starts moving in this particular direction with 20 meter per second at an angle of 30 degree, actually. Okay. Yeah. So what you have to do is determine U and V. Find U and V. Come on, do it.
Oh, we know the mass is okay.
I hope you understood the question though.
Yeah, 1 second. Can I turn on a light?
Yeah, sure.
In here. I'm also gonna get myself some water. I haven't. Sorry about that. Cool question. I assume since we have the angle and whatnot, we essentially resolve vectors and then it's linear momentum all over again. Oh boy, don't you just love linear momentum? Need a better place to keep this notepad. Is this calculator allowed or oh no, but it's 30 degrees,
Yes, you
so
can.
we shouldn't need it.
You can use calculator.
Okay, but is it sin 30 is equal to U. Well no, we have sine 30 as vertical component of the fancy V, which is what I've labeled 20 meters per second with. So then in that case, that means that 5U must be equal to 5U must be equal to 20 sine 30. Well, not just 20 sine 30, because 20 sine 30 is the whatever, it's 20 times 15 sine 30. Because again, this is momentum. So that's always fun. If we know, okay, 20 times 15 is 300, I think. Yes. 300 sine 30 is equal to 5U. Sine 30, of course, being equal to 1/2. So 5U is equal to 150. So therefore U is equal to 30 meters per second. And then as for V, 10V is equal to same equation, just 15 times 20 costs 30. And the only issue is that cost 30 does not have, it has an exact value, it's just not a very nice value to deal with. What that means is that it's 300 cos 30 times v. We can pretty much just divide both sides by 10, so that's 30. And 30 times, well, cos 30 is equal to root 3 over 2, which means that essentially it's just 15 root 3 is equal to v. So
Super, very nice. Everything's perfect. Super. Yeah. So whatever you get, that's the right answer. Yes.
so for the first one, I got, or for you, I got 30 meters per second. I hope
30.
that's right.
30, right?
30. 30, yeah.
Yeah. Yes, that's correct.
And then
Okay.
for the second one, I got 15 times root 3. So
Yeah, looks correct. 15 times root 3, so that is 150 root 3, so 15 times root 3. Perfect. Yep, absolutely. All right, so let's do the next question now. Okay, very good, shabash. So here, this is another type. Now here, what actually happens, we are learning two-dimensional explosion. Okay, let's understand the two-dimensional explosion of a bomb.
okay.
Let's say that we have this 100 kilogram mass. Okay, 100 kilogram explosive. Now it exploded, and now we are investigating like how it must have exploded. Okay, this 100 kilogram thing exploded. So initially it is at 0 meter per second. It is at rest basically. Initially at rest. Initially at rest. Okay. Then what happens? That it when it exploded in basically 4 parts, like this. Yeah. So this is how it actually got exploded in 4 parts. So this is, let's say, 25 kg. This is 25 kg. This is 30 kg, and this one is 20 kg. Okay. Now this is at
Which
an
one's
angle
50
of
kg? 25, 25, 50, 20 plus 30 is 50. Okay.
Yeah.
My bad.
And this one is at 60 degrees. Okay. Now this 25 kg has basically gone in this direction with 30 meter per second. Actually, this 30 kilogram block has gone in this particular direction with 10 meter per second. Okay. Yeah. And then this 25 kg is going in this particular direction with u, and this is going in this direction with v. Determine u and v.
Interesting. Momentum. If I can just. Wait. Okay, this is a weirder question to approach, but I think I found an approach. Because momentum is conserved and, forces act in pairs and all of that, essentially, I guess what we're trying to look for is look at the components of the 30 and 25 kilogram
Yes.
mass, and essentially we want them plus V or U to equal to 0. In other words, it minus V or whatever, it minus V, it plus V is equal to 0. Well, probably plus V because, V is negative, U is negative along the vertical axis, et cetera, et cetera. So one thing we want to say is that we have two, what is this, 25 times 30 sine 30 is equal to, wait, what? No. Oh yeah, is equal to u sine, or negative u plus, what is it, 10 and 300 sine 60. So, okay, those are already some weird values. 25 times 30, I don't really need to do that much math, but it might be easier to do 25 times 30, 750. 750 times 1/2, which is again
370.
numbers 355. No,
375.
let's no.
370.
Yeah, 375. My bad.
Mhm.
Sorry, I'm not the smartest. Is equal to minus u plus 300 sine 60 is root 3 over 2 again. 3 over 2, so that's 150 root 3 over 2. So minus u plus 150 root 3 is equal to 375. Oh God, why? This root 3 is really messing with me. Is it okay if I approximate it to like 26? Because I figured I used the calculator to find the value on the previous question, so it might just be easier if I just do 26.
All right.
U plus 26 is, oh wait,
You got
that whole thing has to
320.
be in parentheses.
You said 325 you are getting. Is it?
What? No. I haven't finished yet.
Okay.
So minus u minus 26 is equal to 375. And then we just add 26 to 375, which is 402. And then u is equal to negative 402. What?
I think you are going a little wrong.
Oh, right. I forgot about the mass. My bad. It has to
Yes.
be, it's 402 over 25, which is 16. About 16. U is about 16. Other than that, then we have to find B. I don't know. I should be able to.
Did you do
convert
this?
to 7.
375 equals to 300 sine 60 plus 25 u. Is it?
Oh, I just kept. Well, actually, hang on. It should be negative 16 because it is in the downward direction. I kept the right side negative just because it is downward. So.
See, when you are equating it, then just take the positive sign only, right?
Okay.
Or-
My answer should still be correct though, because I kept the minus in
Okay.
parentheses outside everything else. So.
Then how about the second part? Second part will be 750 cos 30 plus 300 cos 60. That is equal to 20.
Hang on, sorry. Can I just
Okay. You do
have a
it.
second? Okay, 750 cost 30 coming from. Okay. Yeah, I see that. Okay, and then that's equal to V. Just 20V alone. 20V alone, cos 30 again is root 3 over 2, so 375 root 3 plus 300 times 1/2, 150 is equal to 20V. I'm gonna have to approximate 732 times 375, 649.5 plus 150. 799.5 on one side is equal to 20V. So if we say 799.5 divided by 20 is equal to 39.975, we can essentially say 40. I mean, we have a 0.5 earlier where if we rounded it up to 650, it would have been a clean 800, so it would have divided nicely, actually. So let's just say 40. Yeah, 40 is equal to V. Although V should be negative 40, because again, in the left. So I'll just make it negative.
Correct. Yeah. All right. Yeah. Okay. All right. So I'm sure you do understand now, like how to apply the law of conservation of momentum. Okay. Besides this, like there is a very famous question which we have already done. I remember doing that thing
Bullet.
and the block. Yeah. So, uh, like, has the school done anything else besides these? Any
No, they
worksheet
did
that
a
the school
very,
gave?
they did a, no, the thing is that we just did some questions on work power energy for most of the class. Some of us got done very quickly because they weren't hard per se. We just made stupid algebraic errors. So we had to correct those a couple times. But other than that, he made a very brief introduction to 2.4 and the fact that we're just going to be doing it and that it's on momentum. But he didn't do much else. So.
All right, Ryan. So it doesn't look like that. Like we have anything left in this particular chapter. Okay. Now, in my next session, I want you to do the difficult question. You be very much prepared. Okay. We will be doing. I will be sending you a test series using the Microsoft Form. Okay, for this particular topic entirely. Okay, and it will be having like the toughest questions ever that has been asked in IB for this particular topic. Okay, so
Okay. So I just want to ask about like angular momentum, circular motion, that sort of thing. Because
we don't
angular
have
momentum,
we don't have angular momentum in our syllabus actually. Okay, but
it's
like
on option B, I know, but I'm just asking out
yes.
of interest.
Okay, okay. Yeah. So see, the thing is, so the angular, like you see here, the linear momentum, the concept of the linear momentum. Similarly, we have the angular momentum, and that is involving the torque, basically. Okay. What like here we are saying that F is equals to delta P over delta T. Okay. So the torque is basically the change in the angular momentum with respect to time, like that. Okay. Now, for understanding the angular momentum, L, that is basically r times p. Okay, the r where r is the moment arm. Okay, and also it is known as I times omega. What is like here you have p is equals to mv, mass into velocity. In case of rotational motion, the inertia is because of the moment of inertia. This is something called a moment of inertia. So this is all new stuff. Like if you want to do the engineering physics, okay, we can actually cover that. Like since we have already done the mechanics entirely, so I'll just give you the test paper, and then after that, like we can actually go ahead in the mechanics with the engineering physics basically. What do you think?
Yeah, that sounds good.
Yeah. So this moment of inertia is a different concept actually, which you need to understand. Like what exactly is the moment of inertia? It is not like simply like the mass. Okay, like if you want to determine moment of inertia, it is actually having a formula mass times r square. Okay, and that too like different shapes have different moment of inertia. Like when I say disk, then disk about its center, it is having moment of inertia which is equals to mr square, whereas about the tangent it is mr square by 2. So all that kind of complications are there. Okay, then for the ring it is different, for the square or the square frame it is different, for the cube sphere everything like having different moment of inertia. Okay, so that involves a heavy use of calculus, okay, to determine the moment of inertia of any object of any shape. Okay, so I believe I think you already know calculus, right?
To some extent, not. I haven't done too much calculus stuff, but I mean, I know very fundamental parts of it.
Okay,
like,
then
rudimentary rather is a better word.
All right, then in that case, we'll be doing the if you want to do the engineering physics, okay, then we'll be doing this one, and without using the calculus. Okay, I can teach it.
Okay.
Like, without
I mean,
calculus.
yeah, but I mean, I could just figure out calculus.
Yeah, it is using like calculus, but not like very extensively. Okay. I'll cover that.
Exactly.
If you have basic idea of the integration derivatives, then just the basic ideas.
Yeah, it should work.
Okay. Anything else that you want to do in this, or like if you want to do some kind of activities in mechanics, then I can actually suggest some lab which you can actually do at home. We can provide you the equipments. Okay. Like we used to give it to Aryan. In fact, I remember like he used to do the experiments at home with the equipments like that we used to provide.
I mean, at
So
the moment, I don't know if I'll have the time, but maybe after the PSAT, I
yeah,
might.
sure. After PSAT, you do let me know. Like in
Yeah, yeah.
does your school give Diwali vacation, by the way?
Yeah, but it's much later. It's like at the late October, start of November. So
Okay, all right. So, well, then do let me know, like, when do you want to do any kind of physics activity? Then, in fact, like, we'll dive into that also. Yeah,
okay, yeah.
all right. Sure. See you then.